Hello, everyone. This is the CircuitPython weekly meeting for May 11th, 2026. It's the time of week when we get together to talk about all things CircuitPython. I'm Dan, and I'm sponsored by Adafruit to work on CircuitPython. CircuitPython is a version of Python designed to run on tiny computers called microcontrollers. CircuitPython development is primarily sponsored by Adafruit. So if you want to support Adafruit and CircuitPython, consider purchasing hardware from adafruit.com. This meeting is hosted on the Adafruit Discord server. You can join anytime by going to adafru.it/discord. We hold the meeting in the hashtag CircuitPython dev text channel and the CircuitPython voice channel. Typically, this meeting happens on Mondays at 2 p.m. U.S. Eastern Time, 11 a.m. U.S. Pacific Time, except when it's on a U.S. holiday. In the notes doc, there's a link to a calendar you can view online or add to your favorite calendar app. We also send notifications about upcoming meetings via Discord. If you would like to be notified about the upcoming meetings via Discord, ask us to add you to the @CircuitPythonista's Discord role. There's a shared notes document that accompanies the meeting and the recording. You can contribute to this document beforehand. The final notes document includes timestamps to go along with the video, so you can use the doc to skip around and view the parts of the video that interest you most. The meeting tends to run 30 to 60 minutes. And after each meeting, we post a link for the next meeting's notes document to the CircuitPython dev channel on the Adafruit Discord. Check the pinned messages to find notes about the next meeting and a link to the notes document. If you'd like to participate but cannot attend, feel free to leave hug reports and status updates in the document for us to read during the meeting. This meeting is held in 5 parts. I'll explain each part as we get to it. So now we'll start the meeting proper, and I will take a timestamp. And we'll start with community news, which is a look at all things CircuitPython and Python on hardware in the community. These items come from our Python and microcontrollers newsletter, which I'll tell you about later at the end of this section. So there were some general news items this week, but they were not about Python and microcontrollers in particular. They were about possible PCB shortages in the coming months due to materials supply problems, and also about Python, desktop Python in general. So I've picked out a couple of projects from the newsletter which look interesting. So first up, I've got the project of the week this week was a project about how to reverse engineer almost any keyboard matrix with Raspberry Pi Pico. Thanishers31 on Instructables has developed a Pi Pico and CircuitPython solution to scan an entire keyboard ribbon cable matrix. It figures out which pins are rows, which are columns, handles diode-protected and key rollover boards, and old simple membrane keyboards. It flags shared power lines and spits out a clean JSON map at the end. This sounds absolutely fantastic for investigating unknown keyboards and how to get them to work with your project. And it uses CircuitPython. Next up, you've got a project called Pulse Train, specifically for the Raspberry Pi Pico RP2040. I imagine it uses PIO. Oh, actually, it says that right here. The code uses the RP2040 PIO subsystem to generate exact pulse trains to drive a digital line, allowing an easy creation of common bit streams used in many protocols. So this is kind of a general purpose thing for generating, sending various protocols. It also sounds really useful, especially if you've got some odd device that has an unusual protocol. So all these items came from the Python and Microcontrollers weekly newsletter, which is a CircuitPython community-run newsletter immediately every Monday. It's edited by Anne, who works for Adafruit, and she does a fantastic job of collecting stuff. There's a link to the complete archives of this newsletter. You can subscribe to it on adafruitdaily.com. If you'd like to contribute your own news, or if you see an interesting project or any other news, please mail cpnews@adafruit.com. We really appreciate your contributions. A lot of the material comes from what people send in to us. Okay. Next up is the state of CircuitPython, the libraries in Blinka. This is a quantitative overview of the entire CircuitPython project. It gives us a chance to look at the health of the project separate from our status updates. We'll talk about the project overall and then separately discuss the core, the libraries, and Blinka. So first up, overall, in the past week, there were 14 pull requests merged by 12 authors. Some names that I haven't seen as often are John Nelson, Cifra, J. Giuliano 77, LZRD, Chris Norse, and Mikey Sklar, who works for Adafruit but has not done so many CircuitPython PRs. And there were 8 issues closed by 4 people and 9 opened by 9 people. Next up is the CircuitPython core, and Scott will tell us about that.
Okay. Thank you, Dan. So for the core, we had 12 pull requests merged from 10 different authors. So infrequent names here are Relic SE, John Nelson, Cifra, Giuliano 77, LZRD, Chris Norse, and Mikey Sklar, as Dan said. So thank you to all those folks. That's awesome that we're getting some new contributors in. We had 3 reviewers, myself, Dan, and Mark, Gambler21. We had 20 open pull requests, so we're comfortably under our goal of 25, which is a single page on GitHub. Issues-wise, we had 7 closed issues by 3 people and 5 open by 5 people, so we're down a couple and have a few people involved. We have 862 open issues that you can see at github.com/adafruit/circuitpython/issues. We prioritize these for Adafruit funded work by Dan and myself and Foamy Guy as well, using the milestone system. We have 2 open issues for 10.2x. We have a new milestone this week, which is 10.3. There's 1 open issue there. So that's basically things we want to do on main before we release them as stable. So main is a pre-release 10.3 at this point. And we had 1 issue not assigned to milestone, but I suspect we've gotten to that already. Either way, we're keeping up and triaging as things come in. That's where we are in the core.
All right, thank you, Scott. Okay, next up, Tim, Foamy Guy, will tell us about the libraries.
Right, thanks, Dan. This section covers all of the CircuitPython libraries, which are hosted on GitHub. We have those in 2 different bundles. There's an Adafruit library bundle, which has 393 libraries in it right now, and we have a community bundle with libraries that are contributed by third parties. That one has 176 libraries in it, for a total right now of 569 libraries that support various bits and bobs and different things on CircuitPython. Over the past week, we had 2 pull requests merged across the libraries in the Adafruit bundle. There were 2 authors for those, thanks to Liz and myself. And then review-wise, we had 2 reviewers, thanks to Scott for doing review as well this week with me. Of the merged pull requests, they were both brand new, only 1 day old. And then remaining after this week, we have 36 pull requests that are still open. The oldest one of those is a draft that's 1,362 days. The newest one is 4 days right now. And issues-wise, we had 1 issue closed and 4 issues opened up by 4 people. So that leaves us right now with 777 issues across all of those Adafruit CircuitPython libraries. And there are 2 of those right now that are labeled as good first issue, which you can find listed over at circuitpython.org/contributing, which is the website where you should go if you are interested in contributing to CircuitPython on the Python side of things. On that page, when you first load it up, you will see a big list of open PRs. Those are links over to GitHub. They're waiting for a person to review, so you could click through. I mean, in some cases, you'll click through to GitHub and there will be a review there, so you're looking for one where you click through and it's kind of submitted, but there's not a review yet. So in that case, if you're interested in getting involved, you can, again, click through to those links and GitHub, read about what the pull request is, and then review the code for spelling, syntax, logic, anything like that. If you have hardware, that's even better. You can test it out using the hardware that you have, and then just leave a comment on GitHub letting us know how it went. If you were able to test it out, let us know how that went. When you looked over the code, did you find anything, or does it look all good to you? Leave all of that kind of stuff in your comment. If you get comfortable with that process and would like to join the review team that we have on GitHub, so you get kind of like notified of new stuff as it comes in, makes it easier to keep track of things and find stuff to review, we can work with you to add you onto there. If you would like to start submitting some of your own code, you can also do that from the same page, circuitpython.org/contributing. If you click over to the issues link using the navigation at the top, you'll see a similar looking list of links over to GitHub, but these ones represent issues, so they don't have a proposed change in place necessarily yet. And if you would like to get involved, you can actually submit the change for resolving that issue. So it could be fixing a bug or adding a new feature, maybe adding a new example, something like that. And so you could code up a resolution to that issue, and then you can submit a pull request with your code. We do have a learn guide for contributing to CircuitPython using Git and GitHub. So if you are uncomfortable, unfamiliar with version control, we have a guide for that. We also have folks who are more than happy to help you out here on Discord. There are sort of a lot of moving parts with the actions and the pre-commit and all the checks and everything. So if you get yourself into contributing, but you're having trouble with any part of the process, just come say hi on Discord. Let us know what you're up to. We would be happy to help you out. We want everyone to be able to contribute in a way that works for them. And then I will leave you with updates over the last 7 days in the libraries. There was a fix in display text, and then over in the Sen6X library, there's now support for the Sen63C, so a different version of that device. If anyone has those sensors, we support that one now with the library. Thanks.
Okay, thank you, Tim. Okay, next up is our section on Blinka. Blinka is our compatibility there for CircuitPython that runs on single board computers like Raspberry Pi. So it lets you run CircuitPython code that's actually running in regular desktop Python in what's called CPython. So in the past week, there weren't any pull requests merged. There are still 14 open pull requests. There are a whole bunch about a certain NeoPixel library and a whole bunch about PIO matter, which maybe could be dispatched in one blow, especially if somebody would be interested in taking the time to review those. That would be really nice. Probably reduce our number of open pull requests. And right now, there were no issues closed or open, and there are 85 open issues on the Blinka library itself. And right now we've got 174 supported boards, so many single board computers and some other different pieces of hardware that are also run under Blinka, like certain kinds of adapters, that USB adapters that do I2C and other things like that. All right, so that's it for the Blinka section, and that's it for our general overview. We'll move on to Hug Reports. So the point of Hug Reports is a chance to highlight folks in the CircuitPython community and beyond for doing awesome things. I'll start, and then we'll go down the list of Hug Reports alphabetically. If you're text only or missing meeting, I'll read your notes when I get to them in the list. So first up, I'd like to thank OE-None or OEN1, I'm not sure, from GitHub, who pinpointed a problem in the 10.2.0 release for some boards that had integral displays. And I'll talk about that in status updates. And thanks to Mikey Sklar, who's working on issues with recent mag tags and their e-ink displays. And then next up is Tim.
All right, thanks, Dan. I have a Hug report for you, Dan, for looking into some issues on the C6 builds and giving me sharing that script to be able to translate those memory addresses into traceback. That was new for me to use that one, so it was cool to see how that works. I've done it with Espressif before, but not the RISC-V one, so that was cool. Thanks. I have also a Hug report for Relic SE, who did some initial work a while ago in a PR for bidirectional I2S. This was a very helpful reference when I was working on I2S in Recently, I had an issue with the way I was handling the B clock in this code. I was able to compare and figure out my issue because of this. So thanks to Relic SC for that. And I have a group hug for everyone else here as well. Thanks.
All right, thanks, Tim. Next up, Relic SE has some hug reports. They're not in the chat, so I'll read them. Thanks to D. Halbert for helping me get hold of hardware to test some issues with the core. And next up, final and last, is Scott.
Hello, thanks to Cadet702, who's been very excited for the hardware in the loop board design stuff that I've been working on, and it's always fun to see that people are excited for what I'm working on.
Okay, thank you, Scott. Okay, that's it for hug reports. Now we'll talk about status updates. That's our time to tell folks what we're up to individually. I'll start, and we'll go through the list of people as before. Take a couple of minutes to talk about what you've been doing and what you're planning to do before and after the current meeting. If a discussion becomes too long for status updates, we can always move it to the In the Weeds section. So I'll start. I have a bunch of things. I submitted a PR to turn off presenting the USB SD card as a USB drive, or to present a mounted SD card as a USB drive. So there's a new setting in settings.toml, so you can just turn that off if you don't want it to happen. This is useful because it's the startup is kind of slow right now when an SD card drive is presented, and there's an ongoing issue about that, actually kind of trying to characterize that and see if it can be improved. But this just allows you to turn that feature off if you want to. As I mentioned, a user found a bug in 10.2.0 that affects boards with integral displays that use the 4-wire protocol internally, and this affects a bunch of boards, like 10 or so. So we'll do a 10.2.1 release soon to fix those boards because they just crash on startup. It's not all 4-wire boards, it's boards that don't use a reset pin. And then finally, I've been spending some time on a bug that first showed up on Chromebooks more than a year ago, where the SAMD UF2 boot drive was not showing up. So if you plugged in, say, Circuit Playground Express to a Chromebook, either the CPlay boot drive didn't show up at all, or it showed up and it didn't work. And this was very hard to debug because it's kind of hard to debug on Chromebooks. They're so locked down. Recently, I updated my development machine to Ubuntu 26.04, and now I have the same problem, and that made it much easier to debug. It's sort of provoked by the firmware update daemon, but it's not really the firmware update daemon's fault. So I have a fix. An LLM was helpful in figuring out the problem in the original code. It adds a small amount of code, but these bootloaders on the SAMD21 are so tight that it's not possible. If we add even a tiny bit of code, they can overflow the 8 kilobytes we allot for the bootloader. So I've been finding various ways of squeezing out some space. One thing that I did is that there's an index.htm file which gives a link to the board URL, and that was a little big, and I moved the board URL to the info UF2 file, and that should be okay unless there's some automation that uses index.htm extensively, but I think not. So I'm testing this, and I'm asked a bunch of teachers who use Chromebooks if they can test it, and if you've encountered this problem also, try it also. And that's it for me for status updates. Next up is Tim.
All right, thank you, Dan. I have been working mostly on I2S in, adding support for that in the CircuitPython core. I have tested on a bunch more devices now. I've done ESP32 testing mostly, but I have now gotten into Raspberry Pi stuff, and I tested on ESP32S3, and there were some issues on both of those, actually. Raspberry Pi port needed some fixing up, and I was able to do that. like I said, by comparing back to Relic SE's original implementation. And then on the S3, there was also an unrelated issue where the recording was coming in at sort of half speed, so it sounded really slow and delayed. Kind of cool, truthfully, but we wanted to get that fixed, so I did figure that out as well. I got all of that stuff cleaned up, get pre-commit passing and everything, submitted a PR with it. It is failing in the C6 boards currently, a couple of them, and I think I know what the issue is with them, or I should say I think I know how to resolve them so that they will at least build, but there is a separate issue on the C6 that I kind of found while I was looking into this, which is my next item here, troubleshooting this issue with boot looping C6 devices. So I found this while I was working on the I2S in stuff, looking into my actions failures, but it's actually a separate deal, and I did a little bit more troubleshooting on it this morning to add some info rather to the issue. But I am going to leave that one alone for now, unless if there's anything that I can test that would be helpful. And so I am going back to start working on this embodiment kit project. So I did a little bit of work on this, I think a week ago or a week and a half ago or so. And I think I talked about it once on the stream, but I'll give a quick overview. It's like a microcontroller that will plug into your computer. You can have an LLM agent that can access this microcontroller in order to be able to infer stuff from the environment. It will have sensors like temperature sensor, light sensor, and a couple others. And it will also be able to express things into the environment. So it'll have a little beeper that it can beep, as well as some lights and a vibration motor, so it can kind of like get your attention to ask you a question or ask you if it's okay to run some command or something like that. And it can also read the environment of the room. Another thing that it will have, it's going to be based on a Feather TFT, the reverse one, so it has a little display. And one of the things I thought would be cool is if we could put a face on it, so the LLM can like send it a command to say, show the happy face or show the waiting face or show the sleeping face or whatever. So I found these cute sprites, and they're really nice. They came as an SVG, so they were easy to scale up and down. I was able to get some scripts to convert those to PNGs, and then some basic display IO code to render them so that it can kind of take different permutations of eyes and mouth and put them together to make different faces, which is kind of cool. So by itself, this will just be kind of like a command line interface. You could control it from your terminal if you want, but the purpose of the guide and the project from my perspective is to hook it into the LLM agent to kind of give it a way to see and quote unquote see and express things into the room. So that is what I will be up to next. Thanks.
Okay, thanks, Tim. Okay, and finally, Scott will tell us about what he's up to.
Hello, so I am, in theory, wrapping up hardware land. I got my P4 GPIO boards back. These are meant to be minimalistic ESP32 P4 boards. Turns out I hadn't connected the flash power correctly, and I have a wire that does, and it works, so that's good. I have a V2 with the correction ready to order, and then I had to do the same fix on the hardware in the loop board. The silk screen there is pretty much done, although I was thinking about whether I should put stuff on the back. I do want to length adjust the RMII traces just to make sure that they're close, and check the USB ones as well. And then it is on to getting the bill of materials, so like matching up to particular parts that JLC has currently. That shouldn't take too long, although it does involve making sure that like my resistor values to go with LEDs are reasonable. And then I'll order both, and I was just debating how many I wanted to order because I really am excited to get hardware in the loop testing kind of scaling up. So I might go a little crazy and get 10 instead of 5. I was also thinking maybe I'll get a swirly grid to fit in these IKEA bookshelves too, where I think these boards are going to end up. After that, I'll either fix IDF6 bugs, I'll do something for Zephyr, or I'll work on the P4 logic analyzer stuff. Although I think actually working on the software side of the hardware in the loop stuff is probably a good idea too. So not quite sure which software stuff I'll pick up in a couple days once the hardware stuff is ordered, but we'll see.
Okay, thank you, Scott. So finally, there's an in the read section that we have if there's any extended thing to discuss, but there isn't anything. So we'll move on to the wrap up for this meeting. Next week, the meeting is again on Monday. It'll be May 18th at the same time. And then the next week after that, Monday is a U.S. holiday called Memorial Day. And so the meeting will be on Tuesday at the regular time instead of Monday. So that's it. Thanks everybody for listening and stopping by. And talk to you next week. Bye-bye.